rounding whole numbers and rounding fractions, which is really what we're going to be looking at, okay? And by fractions, we may want to consider calling this mixed numbers. Okay, so I don't want to spend a whole lot of time on rounding, but rounding is essentially just finding a number that is close. Okay, and we use that to estimate, which is our second aspect of what it is. Okay, finding a number that is close. Now, when we find a number that is close, we can do two things. We want to know close to what? What are we trying to find a number that it's close to? Close, we're basically saying a certain place value. Do you guys know what the population of Denver is?
No.
Anybody know the population of Denver? We live in this area. We should probably know, right?
Yeah.
What is the population of Denver? Okay. What did you say? 4.2 million, you think? All right. So I heard 4.2 million. Should we check it out? Now, wow, we're way off. Okay. It's not 4.2 million. That was but this is perfect, okay? We have 619,000. Hold on, but look what year that was. 2011. 619,968. Now, I got a problem with that population, even if it was 2011. 968. Do you understand this idea that people born and die like all the time? So this number would fluctuate. So at the time, this is probably not a very significant number. If you had to tell somebody about what the population in 2011 was, about how many would you say this is? 600,000? I'm even thinking a better estimate. 600,000 is not bad.
620,000?
Yeah, because I'm looking at this, and I would probably, because this is 9, if we were rounding to the 100,000s place, I could see this easily as 600,000. If we were rounding to the 10,000s place, 620,000. Right? Because we're looking at those particular place values. Yes?
To the bottom it says, what is the population of Denver in 2019? I think that would probably be more accurate.
You think so? So let's go to 2019, because now that was just last year.
Oh, 20.
What is the population? That's Colorado. Let's go right here.
Oh, wow.
Now, did we really grow that much in 9 years? Do you think that's an exact population, or do you think that's an estimate? Why is it an estimate? Because apparently there's no thousands or anything else. Now, as I look at that population, what did they round to? The nearest what? Nearest 10,000s. That's exactly it. But now as I come down here, this says 2017, 60 more rows. Let's see what this says way down in 2011. As we move down, 2011, I don't really, there we go. Let's see, 2011. This is saying about 2 million. You know, regardless, doesn't matter. So, rounding, we look at a certain place value. That is our key. Now, if we rounded on a number line, and we thought about this number 283, and we can look at a lot of different things here. We could look at a number line where here we would have 0, 100, 200, 300, 400. And we look at 283, right here would be like 250. 283 would be somewhere over here. 283 is closest to which 100? Yeah, so we would round this to about 300. But in the same manner, we could also look at this as, maybe we run it around the tens. So as I look at this, I could have 250, 260, 270. Whoops, that's about 270. 270, 280, 290. And 283, if I find that midway point, 285, 283 is here, so 283 would also round potentially to 280. So when we do our rounding, what are we really focused on? What number? What's our magic number? What's our magic number? 5. Okay, 5. If we have a 43210 or a 5, 6, 7, 8, 9, with these numbers here, we round down. With these numbers here, we round up. Something itchy. Maybe my wife washed this, and it's got like fuzz on the inside, so it's tickling me. Does that make sense, you guys? Okay. You know, and when we talked about these things, we can look at it with fractions too. As we look at mixed numbers, if I had 4d8 and 5/7, what's my nearest whole number? What's my nearest whole number? 49. Because 5/7, you know, 5/7 is greater than 1/2, so this could become 49. But I also like the idea, here we got 48 and 5/7. If we wanted to round to the tens place, maybe it would be 50. If we round to the tens place. It kind of depends on what our ultimate goal is. Fair enough? So, I think you guys remember this. This is why we're doing 2 lessons a day because of this lesson here. Let's define one other word real quick. Estimate. E-S-T-I-M-A-T-E. Estimate. To estimate means that we round our original numbers to find, you know what? I'm going to say to perform an operation that gives us a close answer. We estimate when we don't need the exact answer. So estimate is something we do before we do the operation. Rounding is something we do to specific numbers. Okay? Everybody good there? Perfect. Let's do the practice problems. Practice problems. Open up your book, page 204. Page 204. A. What number do they have in A, Caden?
1,760.
Perfect. A, 1,760. And what do they want me to round that to? So here's what I'm going to do. I'm going to underline, if you guys remember, we're going to underline the ones, or the number we're rounding to, and we're going to put a box around the number before it. Does 6 tell me to go up or down? Up. So if I need to, I can put a little up there. The up goes to this, so 1,800. 1,800. In other words, if you don't understand this, is 17,600 closer to 1,700 or 1,800? That's really what we're looking at. What's the 100 before it? What's the 100 after it? Which one is it closest to? Does that make sense? So B. 5,489. 5,489. What place do they want me to round to, Lexi? Thousands. Okay, so this time we're going to do it a little bit different. Let's do the second part first. What 2 thousands is this between? 5,000, 6,000. 5,000 and 6,000. Those are the 2 thousands it's between. Is 5,489 closer to 5,000 or 6,000? Sebastian?
5,000.
Because 500 would be the halfway point, right? So good. 5,000. So you saw 2 ways we could do it. One, identifying the numbers before and after. Do number C any way you want. Stand when you got your answer. Number C. 186,282. Stan, when you got your answer. The number we rounding to the nearest what? Nearest thousands. So my 6 is in the thousands place. I look at the 2. This should become 186,000. Because it is between 186,000, 187,000, 186,000. Does it make sense? I'm going to give you a challenge one. Have a seat. We're going to call this problem X. Problem X is 39.98. I want you to round that to the nearest tenth. Not 10, nearest tenth. What would this number be to the nearest tenth? Go. If I look at my tenths, this is between 39.9 and 40.0. If I look at my 10th place, the 8 tells me to go up, which makes this a 10, which makes this a 10, which makes this... To round to the nearest 10th, we have to keep the 10th place. So there has to be that 0. Does that make sense? Okay, have a seat. You'll see those occasionally. Make sure you got it. All right. D, estimate each answer. So first thing we're going to do for these is we're going to write down the original problem. So as I look at D, we got to subtract from 7,986 minus 3,074. 7,986 minus 3,074. We got to decide. We want to estimate this. To estimate, we make numbers we can do basically in our head. What is 7,986 round to? 8,000. Now, it would be 8,000 if we rounded to the hundreds. It would be 8,000 also if we rounded to the nearest thousand. So I'm going to change it to 8,000 minus 3,074 becomes?
3,000.
3,000. Answer is 5,000. 297 times 30. 297 times, is it 30 or 29?
31.
31. Oops. What are you going to round 297 to?
200.
What are you going to round 31 to?
30.
Can I round 1 to the hundreds place, 1 to the tens place? Yeah. 300 times 30, 0, 0, 0, 9. 9,000? 58,600 divided by 19. 58,600 divided by 19. What might you change?
Like 58,600, 60,000?
You know what? I probably would. I toyed in my head, do I make this into 59,000 or do I make it into 60,000? Why would I choose 60,000?
Because 20 goes into it was
That's exactly why. Because your point of estimation is you want to pick numbers it can go into. So I am going to say 60,000 divided by 20. And if I do my canceling, 0, because 10 goes in, 2 goes into 6, 3, my answer is 3, 0, 0, 0, 3,000. Yes, sir?
In the problem, it says 5,000.
Oh, yeah.
Whoa, so we went way big. So we would get one more 0. Boop, boop. Good catch. That is what I mean by not just copying. Nice job, Kaden. But if we did it the other way, we would have been right through, if that was the original problem. You ever do that on your homework? Copy the wrong thing? G, last one. 12 and 1/4 divided by 3 and 7/8. What whole number does 12 and 1/4 round to, Sebastian? 12. What is 3 and 7/8 round to, whole number wise? Noah? What is it? 7/8 is more than a half, so it makes it go up. 4. Yeah, 12 divided by 4 is 3. Simple enough. Last one. Calculate the area of this rectangle. After calculating, check the reasonableness of your answer. So in other words, what they're telling us to do is they're telling us to find the actual area and then estimate to see if your answer makes sense. So as I look at that problem, we got a rectangle. The rectangle has a length of 1 7/8 and a width of 1 1/8. 1 7/8, 1 1/8. So Caden, we've done them a couple times now. For the area of a rectangle, I draw the picture. What's my next step? No. What's my next step in the work? What am I going to show?
Formula?
The formula. I want to see area equals length times width. You remember talking about that, Caden? They did it all last year, so I knew they'd remember. You need to get in the habit now. Now, after we do length times width, we say what length is. Length equals width equals. Caden, you're going to write this down. And then we're going to say them, right? Perfect. So 1 7/8, 1 1/8. So area equals 1 7/8 times 1 1/8. All right. How do I multiply fractions? Kaya, you've been gone. You can help me out. How do I multiply fractions?
You make it improper.
Perfect. Perfect. Make them improper. 1 times 8 is 8 plus 7 is 15. So area equals 15 over 8 times 9 over 8. Yeah. Does anything cancel? No, William, so how do I do this?
Just multiply the numerator by the numerator and the denominator by the.
That's exactly it. Hey, how can we do 15 times 9 in our head? Does anybody know? Yeah, we could do that. 9 times 10 is 90. 9 times 5 is 45. Add it together, we get 135. In my head, I was thinking I would do 10 times 15 is 150, minus the extra 15, that's 135. Nice job, Caden. I'll give you credit. Nice job, Aiden. So area equals 135 over 64. 135 over 64 becomes 2, which is 8. 128 subtract 7. So 7/64. 2 7/64 inches squared. Let's see if our answer is reasonable. I'm going to come back up here, use blue real quick. 1 7/8. What is 1 7/8 round to?
2.
2. What is 1 1/8 round to?
1.
1. So if area equals length times width, and my length is 2 and my width is 1, area equals 2 times 1 is 2 inches squared. Is that a pretty good assumption? I'm right there on track? Yeah. I think that's a good one. All right, lesson 30, our second letter today. The first part of this is common denominators. Common denominators. Basically, common denominators is a denominator that two fractions could both share. Okay? A denominator that two or more fractions could share. So a common denominator, I'll write that word again, common denominator would be a common multiple. So the common denominator is basically the common multiple of two different numbers. So if I look at 2/3 and 1/4, we pick two easy ones. 2/3 and 1/4. And I look at 3, 6, 9, 12, 15, and I look at 4, 8, 12. That's my common denominator. And I know you could have probably done 2/3 and 1/4 in your head. So 2/3 times, here's something about this. This is my first number, second number, third number, fourth number. That's why it's times 4 over 4. Equals 8 over 12. This one right here is my first number, second number, third number. So 1/4 times 3 over 3 is 3 over 12. And if we wanted to add those together, we could get 11 12. If we want to subtract them, we would get something different. Any questions with that? All right. So using common denominators, we can do something like this: 5 6 and 7 9. We can compare these two numbers. If I do a picture 5 6 7 9, I'm going to guess we can't draw it super accurately. But what we can do is we can find out common denominator. What number does 6 and 18 both go into?
18.
Well, did I just tell you what it was? 6 and 9 both go into? Surprise me. 18. Holy cow, that's exactly it. You know, and if you have trouble with that, remember, 6. We have two different ways we can do it. 6, 12, 18, 24, 9, 18. So we see it's 18. Or we could have done factoring. 6 is 2 and 3. 9 is 3 and 3. So if 6 is 2 times 3 and 9 is 3 times 3, my least common multiple is 2 times 3 times 3, which is 18. And I just want you to see those because as numbers get bigger and bigger, guys, this is the easiest way to do it. All right, so let's make them common numbers. 5 6 becomes what? 6 times 3 is 18, so 5 times 3 is? So this is 15 over 18. Times 2 over 2 is 14 over 18. So 5 6 is greater than 7 9. And if you stop and you think about that, I don't think you could have drawn a circle that was different by 1/18. Does that make sense? Perfect. All right, so open up your book to page 210. It gives you things that we've already been doing. Number 3 says put them in order. So make them all common denominators so we can do it. Example number 4, example number 5, example number 6 are addition and subtraction. So is example number 7. Number 8 tells you to use prime factorization to help you out. So we're going to do that in H and I. We'll look at what they did. They used the prime factorization to find what the least common multiple is, because the least common multiple is the same as the lowest common denominator. So learning those patterns helps us out. So let's go with A. Practice problem A. Practice problem A says 3/5 compared to 7/10. Now I'm going to look at the directions to see if there's anything that they need me to show. It says write the fractions so they have common denominators, then compare the fractions. So they need common denominators. What number does 5 and 10 both go into?
10.
I would use 10. 10 would be the least common multiple. It's the smallest one they both go. So this becomes 6/10. And I would just put it underneath. 6/10 compared to 7/10. What's my sign? Is not a sign. Plus sign. This side is less than this side, so we got less than. B. 5/12 and 7/15. 5/12 and 7/15. 2 times 2 times 3 is 12. 15 is 3 times 5. So my least common multiple is 2 times 2 times 3 times 5 is 60. So the number that goes into bold that they both go into is 60. So something over 60 compared to something over 60. I'm going to use blue real quick to show you what we're doing here. 12 has a 2, 2, 3. So here's a 2, 2, 3. 12 needs to multiply by 5, so 5 needs to multiply by 5. Give me 25. As I look at 15, I'll use red. 15 has a 3 and a 5. A 3 and a 5. What does 15 still need to get to 60? Taylor? 3 and 5, 3 and 5. What does it still need? And a bro.
2 2.
2 twos. Taylor, there's a 3, there's a 5, there's a 3, there's a 5. What's left? 2 twos. Go back to the blue one because I think you copied without paying attention. Here we go, Taylor. If I have a 2, and a 3 for 12, a 2, 2, and a 3, what was left? 5. That's why we multiplied by the 5. This is why we're going to multiply by 4. So red times 4 times 4. 15 times 4 is 60. This becomes 28. What's my sign, Sebastian? Less than sign again. Less than sign again. C. Use common denominators to arrange these fractions. 1/2, 3/10, 2/5. C. 1/2, 3/10, 2/5. What number does 2, 10, and 5 all go into? 10. Guys, if it's a simple number, we'll just do it. 5/10, 3/10, 4/10. What's my smallest number?
3/10.
Next smallest?
4/10.
We have to go back to the original, so it is 2/5 followed by 1/2. Your final answer needs to reflect the original numbers. Fair enough? All right, so D, E, F, G. Adam, after you've added them, stand up and we'll look at them together. Let me give you a quick hint. As I look at D, my factors, I usually look at my two smallest numbers. So what number does 4 and 6 both go into? 12. And then I ask myself, does 8 go into 12? No. So what is the next multiple of 12? 24. Does 8 go into 24? Yes. So that becomes my least common multiple. So when I have three numbers, pick the two smallest and then use the multiples of the two smallest numbers. So 24. 4 times 6, 3 times 6. 6 times 4, 5 times 4. 8 times 3, 3 times 3. 18 plus 9 is 27. 47. 47 over 24 is 1. And 23 over 24? 612, what's my least common multiple? 6. Multiply this by 3 over 3. So I have 7 and 5, 6 minus 2 and 3, 6. Becomes 5 minus 3 is 2, 6. 5 and 2, 6, which becomes 5 and 1/3. Any questions? So you understand? Any questions? All right, look at the next one. F. What's the common multiple? 8. So this time I'm going to just change the fraction. So 6/8 plus 5/8 is 11/8. 5 plus 4 is 9. I like to take my 11/8 and make that 1 3/8, so my total becomes 10 3/8. What's wrong? Sorry. Anybody who missed it, do you understand what you did wrong? Do you have any questions? Okay. So look at the last one, 4 and 1, 6, minus 2 and 5 9. Again, what number does 6 and 9 both go into? We did it earlier. 18. 6 times 3. 1 times 3 is, whoops, not 9. 3. 9 times 2. 5 times 2, 10. 3/10 minus 10/10 is, or 3/18 minus 10/18. I can't do. So I have to borrow. Sebastian, if I borrow, what do I get? 4 becomes? Yeah, because 18 plus 3, 21. 21 minus 10 is 11/18. 3 minus 2 is 1. 1 and 11/18. Now we lost about half the class. Is there anything you don't understand? Yes.
For G, I accidentally did, instead of 18, I put 54.
Okay, but that would have been okay. So if you did 54, that would have been what? Times 3? So 33 over 54?
Yeah.
Now let's look at that real quick. 1 and 33 over 54. 3 plus 3 is 6. 5 plus 4 is 9. So what does that tell you?
It's divisible by 3.
It's divisible by 3. So then we would just have to simplify that. You could have got 118. Make sense? Nice job, those who got it. Have a seat. I want to do H with you so you can do I alone. It says to use prime factorization to help you add or subtract these problems. So 25 over 36 plus 5 over 60. 25 over 36 plus 5 over 60. So the real question comes, what is my common denominator? So we factor 36 and we factor 60. 36 is 6 times 6, 2 times 3, 2 times 3. 60, 6 times 10, 2 times 3, 2 times 5. So 36 is 2 times 2 times 3 times 3. 60, 2 times 2 times 3 times 5. My least common multiple is 2 2s, 2 2s. How many 2s are we going to take?
2.
2. 2 3s, 1 3. How many 3s are we going to take?
0.
Got to have both of them. If we don't have 2, we can't make 36. So I'm going to take 3 and a 3. No 5, 1 5. How many 5s are we going to take?
1.
1 5. Okay. So this is going to be our common denominator. 2 times 2 is 4. 4 times 5 is 20. 20 times 9 is 180. So my least common denominator is 180. So if I come back up here, this has to be over 180. This has to be over 180. Now to help you see it, I'm going to use a highlighter. 36 is 2, 2, 3, 3. My common denominator is 2, 2, 3, 3, 5. What number is missing? 5. So I have to multiply this by 5 over 5, which becomes 125. $60. I'll use another color. Let's go with blue. 2, 2, 3, 5. 2, 2, 3, 5. What number is missing?
3.
So I have to multiply this by 3 over 3, and I get 15. So 125 plus 15 is 140 over 180. Simplify. Cancel, cancel, because 10 goes in. 2 goes in, and I get 7 over 9. 7 over 9. I want you to follow those steps to do I. Find the common denominator using factors. Do number I. Nancy? So let's take a look real quick. If I did the factoring for 25, what does 25 become? 5 times 5. If I did the factoring for 45, what does it become? 3 times 3 times 5, right? Because 3 times 3 is 9 times 5, okay? So now my least common multiple is 2 3s and 2 5s. 3, 3, 5, 5. Because to make 25, I have to have 2 5s. To make 45, I have to have 2 3s and a 5. So I'm going to take 2 3s, 2 5s. So this one here times 25 has a 5 and a 5. The LCM has a 5 and 5. What do I need to multiply by? 9. Times 9 over 9 becomes, by the way, this is 3 times 5 is 15. 3 times 5 is 15. This is 225. So something over 225, 27, minus, times, 45 is 335, 335, I need one more 5, multiply by 5 over 5, and I get 10 over 225. Do the subtraction, 17 over 225. If you don't have it, make sure you do. It's just an easier way to come up with the least common denominator. Okay? So, for homework, notice last time we did 27. We did 27, a lot of that together. Today, we are skipping 28. You've got 29, all. 29, all. You can turn in last night's work to the front of the room, and then your homework, 29 all.